Venus, the hot, hellish and volcanic planet. Venus, the second planet from the Sun, is named after the Roman goddess of love and beauty and is the only planet named after a female. Venus may have been named after the most beautiful deity of the pantheon because it shone the brightest among the 5 planets known to ancient astronomers. In ancient times, Venus was often thought to be 2 different stars, the evening star and the morning star, that is, the ones that first appeared at sunset and sunrise. In Latin, they were respectively known as Vesper and Lucifer. In Christian times, Lucifer, or light bringer, became known as the name of Satan before his fall. However, further observations of Venus in the space age show a very hellish environment. This makes Venus a very difficult planet to observe from up close because spacecraft do not survive long on its surface. Physical characteristics. Venus and Earth are often called twins because they are similar in size, mass, density, composition and gravity. The size of Venus is only a little smaller than our home planet, with a mass that's about 80% of Earth's. The interior of Venus is made of a metallic iron core that's roughly 2,400 miles (6,000 kilometers) wide. Venus's molten rocky mantle is roughly 1,200 miles (3,000 kilometers) thick. Venus's crust is mostly basalt, and is estimated to be 6 to 12 miles (10 to 20 kilometers) thick, on average. Venus is the hottest planet in the solar system. Although Venus is not the planet closest to the Sun, its dense atmosphere traps heat in a runaway version of the greenhouse effect that warms Earth. As a result, temperatures on Venus reach 880 degrees Fahrenheit (471 degrees Celsius), which is more than hot enough to melt lead. Spacecraft have survived only a few hours after landing on the planet before being destroyed. The atmosphere on Venus is hellish as well, consisting mainly of carbon dioxide with clouds of sulfuric acid, and only trace amounts of water. The atmosphere is heavier than that of any other planet, leading to a surface pressure that's over 90 times that of Earth, similar to the pressure that exists 3,300 feet (1,000 meters) deep in the ocean. Incredibly, however, early in Venus's history, the planet may have been habitable, according to models from researchers at NASA's Goddard Institute for Space Studies. The surface of Venus is extremely dry. During its evolution, ultraviolet rays from the sun evaporated water quickly, keeping the planet in a prolonged molten state. There is no liquid water on its surface today because the scorching heat created by its ozone-filled atmosphere would cause water to boil away. Roughly 2/3 of the Venusian surface is covered by flat, smooth plains that are marred by thousands of volcanoes, some of which are still active today, ranging from about 0.5 to 150 miles (0.8 to 240 kilometers) wide, with lava flows carving long, winding canals that are up to more than 3,000 miles (5,000 kilometers) in length, longer than on any other planet. 6 mountainous regions make up about 1/3 of the Venusian surface. One mountain range, called Maxwell, is about 540 miles (870 kilometers) long and reaches up to some 7 miles (11.3 kilometers) high, making it the highest feature on the planet. Venus also possesses a number of surface features that are unlike anything on Earth. For example, Venus has coronae, or crowns, ring-like structures that range from roughly 95 to 1,300 miles (155 to 2,100 kilometers) wide. Scientists believe these formed when hot material beneath the crust rose up, warping the planet's surface. Venus also has tesserae, or tiles, raised areas in which many ridges and valleys have formed in different directions. With conditions on Venus that could be described as infernal, the ancient name for Venus, Lucifer, seems to fit. However, this name did not carry any fiendish connotations. Lucifer means light bringer, and when seen from Earth, Venus is brighter than any other planet or even any star in the night sky because of its highly reflective clouds and its closeness to our planet.
To understand what a powerful force the Sun can be, take a look at Venus. At almost exactly the same size and mass as Earth, it's truly our sister planet. The thinking is that long ago, fierce solar winds stripped off lighter water molecules from its upper atmosphere. What was left was a witch's brew of acidic gases and carbon dioxide that thickened at lower altitudes, rising to some 90 times the density of Earth's atmosphere. At a concentration of 95% in Venus' atmosphere, CO2 gas trapped increasing amounts of sunlight and drove surface temperatures close to 1,000 degrees Fahrenheit. How did our Earth avoid such a harsh fate? One of the main reasons is that our planet has what Venus lacks: a natural defense against solar attacks. Earth spins around on its axis once every 24 hours. This has an effect on molten iron welling up from deep in its core. It's kind of like the alternator in your car. These plumes of hot metal generate magnetic fields that extend beyond our atmosphere and enshroud the Earth in a protective field. Venus, on the other hand, spins so slowly that one of its days is 243 Earth days long. That's one reason it lacks a strong magnetic field. While Earth's magnetic field may be strong, it's not impenetrable. In fact, when the Sun shoots a CME in our direction, and that blast coincides with Earth's magnetic field, that chain of events is called a geomagnetic storm. Air travelers, whose routes fly near the poles, get a slightly increased dose of radiation, and the crews who fly them often need to keep track of their cumulative exposure. But space travelers are at much greater risk. Earth's atmosphere thins rapidly with increasing altitude. Outside its protective envelope, those living on space stations get twice as much radiation as the rest of us, even when the Sun is quiet. When it erupts, as it did in 2003, astronauts and cosmonauts can absorb a whole year's radiation dose in just a couple of hours. With our dependence on computers and electronic communications growing by the day, we have begun to launch a fleet of spacecraft to monitor the Sun. Some positioned in low Earth orbit, others out where our magnetic field meets the solar wind, and even beyond. Data from these satellites are revolutionizing our understanding of the Sun and helping scientists predict solar eruptions more accurately than ever before.
Orbital characteristics. Venus takes 243 Earth days to rotate on its axis, which is by far the slowest of any of the major planets. And, because of this sluggish spin, its metal core cannot generate a magnetic field similar to Earth's. The magnetic field of Venus is 0.000015 times that of Earth's magnetic field. If viewed from above, Venus rotates on its axis in a direction that's the opposite of most planets. That means on Venus, the Sun would appear to rise in the west and set in the east. On Earth, the Sun appears to rise in the east and set in the west. The Venusian year, the time it takes to orbit the Sun, is about 225 Earth days long. Normally, that would mean that days on Venus would be longer than years. However, because of Venus's curious retrograde rotation, the time from one sunrise to the next is only about 117 Earth days long. The last time we saw Venus transit in front of the Sun was in 2012, and the next time will be in 2117. Here are some of Venus's parameters, according to NASA. Average distance from the Sun, 67,237,910 miles, 108,208,930 kilometers. By comparison, 0.723 times that of Earth. Perihelion, closest approach to Sun, 66,782,000 miles, 107,476,000 kilometers. By comparison, 0.730 times that of Earth. Aphelion, farthest distance from Sun, 67,693,000 miles, 108,942,000 kilometers. By comparison, 0.716 times that of Earth. Climate on Venus. The very top layer of Venus's clouds zips around the planet every 4 Earth days, propelled by hurricane-force winds traveling roughly 224 miles per hour, 360 kilometers per hour. This superrotation of the planet's atmosphere, some 60 times faster than Venus itself rotates, may be one of Venus's biggest mysteries. The clouds also carry signs of meteorological events known as gravity waves, caused when winds blow over geological features, causing rises and falls in the layers of air. The winds at the planet's surface are much slower, estimated to be just a few miles per hour. Unusual stripes in the upper clouds of Venus are dubbed blue absorbers or ultraviolet absorbers because they strongly absorb light in the blue and ultraviolet wavelengths. These are soaking up a huge amount of energy, nearly half of the total solar energy the planet absorbs. As such, they seem to play a major role in keeping Venus as hellish as it is. Their exact composition remains uncertain. Some scientists suggest it could even be life, although many things would need to be ruled out before that conclusion is accepted. The Venus Express spacecraft, a European Space Agency mission that operated between 2005 and 2014, found evidence of lightning on the planet, which formed within clouds of sulfuric acid, unlike Earth's lightning, which forms in clouds of water. Venus's lightning is unique in the solar system. The lightning is of particular interest to scientists because it's possible that electrical discharges from lightning could help form the molecules needed to jumpstart life, which is what some scientists believe happened on Earth. A long-lived cyclone on Venus, first observed in 2006, appears to be in constant flux, with elements constantly breaking apart and reforming. Research and exploration. The United States, Soviet Union, European Space Agency and Japan Aerospace Exploration Agency have deployed many spacecraft to Venus, more than 20 so far. NASA's Mariner 2 came within 21,600 miles, 34,760 kilometers, of Venus in 1962, making it the first planet to be observed by a passing spacecraft. The Soviet Union's Venera 7 was the first spacecraft to land on another planet, having landed on Venus in December 1970. Venera 9 returned the first photographs of the Venusian surface. The first Venusian orbiter, NASA's Magellan, generated maps of 98% of the planet's surface, showing features as small as 330 feet (100 meters) across. The European Space Agency's Venus Express spent 8 years in orbit around Venus with a large variety of instruments and confirmed the presence of lightning there. In August 2014, as the satellite began wrapping up its mission, controllers engaged in a month-long maneuver that plunged the spacecraft into the outer layers of the planet's atmosphere. Venus Express survived the daring journey, then moved into a higher orbit, where it spent several months. By December 2014, the spacecraft ran out of propellant and eventually burned up in Venus's atmosphere. Japan's Akatsuki mission launched to Venus in 2010, but the spacecraft's main engine died during a pivotal orbit insertion burn, sending the craft hurling into space. Using smaller thrusters, the Japanese team successfully performed a burn to correct the spacecraft's course. A subsequent burn in November 2015 put Akatsuki into orbit around the planet. In 2017, Akatsuki spotted another huge gravity wave in Venus's atmosphere. The spacecraft still orbits Venus to this day, studying the planet's weather patterns and searching for active volcanoes. As of at least late 2019, NASA and the Russian Academy of Sciences Space Research Institute have discussed collaborating on the Venera D mission, which would include an orbiter, a lander and perhaps a solar-powered airship. We're at the pen and paper stage where we're considering what science questions do we want this mission to answer and what components of a mission would best answer those questions, Tracy Gregg, a planetary geologist at the University at Buffalo, told Space.com in 2018. The earliest possible launch date we'd be looking at is 2026, and who knows if we could meet that. In recent years, NASA has funded several extremely early-stage mission concepts that could look at Venus in the coming decades, under the NASA Innovative Advanced Concepts program. This includes a steampunk rover that would use old-school levers instead of electronics, which would fry in Venus's atmosphere, and a balloon that would check out Venus from low altitudes. Separately, some NASA researchers have been investigating the possibility of using airships to explore the more temperate regions of Venus's atmosphere. Please hit the subscribe button, and leave a comment below. Thanks for watching.